Hello and welcome to pointers. A pointer is a variable-like reference that holds a memory address to another variable or array. Some tasks are performed more easily with pointers, and on your screen right now you would see why pointers are great to use. So let's do it. Let's create an initial variable. Let's call it age. So let's say age is equal to 25. Okay, and like we've said before, using memory address, in every variable, there is what we call the left side and the right side. The left side is where the memory address is, or the address of this variable, and the right side, this one, is the value. So let's print them out. Printf. So I'm going to print out first the address of the variable. So to print address of the variable, let's say left side, okay, is equal to, left side is address. Yeah, left side is address. So let's print out the address. So to print out the address, you use P and you reference it with the memory address, so H. Then also, the right side is the value. Right side is value. And you don't need this. So let's print these guys out before we proceed. Oh, sorry, new character, new line. Clear output. So as you can see, oh sorry, format specifier is there. So we turn this back to D for integer. Alright, so what I've done now is I declared a variable, then I'm printing the left side, which is the address of age, and I'm printing the right side, which is the value of age. So let's see that now. So as you can see, left side is address, and this is the address, which is an hexadecimal number, and this is the right side, which is the value, which is 25. But like we just said here, we said a pointer is a variable-like reference that holds a memory address to another variable. That is to say, we can store this memory address of age in another variable, and that variable is called the pointer. So now the pointer would now point to the address of this variable. Remember we said before that in the memory blocks are like the houses. So your memory is a street. Then you have the memory block that stores the value or the person. Then inside of this, for all these memory blocks or all these houses, you have an address. So if you want to tell someone to visit you, you will be like number 23 Precious Avenue. That is your pointer. That is your memory address. So now we want to store that memory address in a variable. And the variable you store it in is called a pointer. So let's do that. So for you to declare a pointer, you always have to ensure that it is the same type with the character, with the variable that you want to store its address. So let's create a pointer. The first way to create a pointer is you can initialize it. Ensure that they have the same data type, int. Then you use a asterisk, okay? You use an asterisk, which is called the indirection operator. Then I like to do mine like this, ptr. So because it's a pointer to age, so I say ptr, pointer, age. And this is going to store this value, this address, this one, ampersand age. So the first way to do a pointer is you can declare it as null, okay? Then you can now come down and say ptr underscore age is equal to age, okay? This is the first way you can use to declare a pointer, these two ways. But I prefer to do it directly, so I'm just going to do it straight up here. So I will comment this out and just do it up here. So it's going to store the address of age. Okay, now it is storing the address of age. As you can see, now we have the first one, which is an integer variable, and now we have another pointer that is storing the address of age. So let's confirm if this pointer is truly storing the address of age. So let me drop down and print out let's print out the value of this pointer. Value of pointer ptr age is equal to okay, so the format specifier. So the format specifier here will also be a p because it's an hexadecimal variable number. Then we put a new line. We need the new line. Let me comment this one out. So we want to get now the value of pointer age, just to confirm. So we are also going to call the pointer here ptr age. So let's confirm it. Let me clear the output here and let's run this. So as you can see now, the left side is address. That is the left side, the address of age from up here is this, and also the value of the pointer age is also storing the address of age. Can you see that they are both the same address for both? So now you see that the value of our pointer is also the address of the variable age. Take note, the value of our pointer is also the address of variable age. And to confirm to you that our pointer is also a variable, we can also print the address of the pointer itself. Interesting, right? So we can do something like this. Let's say address of pointer is equal to p, and yes, the way we get address ptr age. So let's run this. Sorry. Oh, print should be printf. So as you can see, the left side of our variable, this variable is the memory address, and this is the memory address. We got it right here. Then also, the value of the pointer, the value of this pointer is also the memory address of this guy. And to show you that our pointer is also a variable, we can also get the address of the pointer. Okay, now let's get the value of our age. And this is age here. We can get the right side already, which is the value, but also we can get the value of age through the pointer. And how do we do that? We use what we call dereferencing. So you say print f. So we say value at the memory address. Remember, the pointer is holding the memory address. Value at the memory address of ptr age is equal to. So right here we specify integer and we dereference it. We use star ptr age to dereference it. So let me put all these guys on new line so that our code will not be clunky. Then let's run this. As you can see, right side value of the variable is 25, and value at the memory address of ptr age is also 25. what have we done here? We've done what we call dereferencing. So what has happened is, remember we said that the pointer is a variable that holds the memory address. But remember we said before that the memory address is like the address of the house. And inside of the house, you can find what's there, the variable. So that's what we've done. From the address of the house, we've been able to find who is living inside of the house. That is what we call dereferencing. So through the memory address, we've been able to find the value. So let's go over it again. In any variable that you declare in C, you have a left side and a right side. The left side is the address of that variable, and the right side is the value of that variable. But also, you can store the address of the variable in another variable which is called the pointer, which we did here. And to prove it, we did it after declaring it and storing the value. We now have to print it out. So we printed the left side, which is the pointer, which is the address of the variable. And we also printed the value of the variable pointer, which also became the address of this variable. And to prove that the variable, the pointer, is also a variable, we also printed out the address of the pointer, which happens to be this. Then we went on to print the right side of the variable, which is 25, and to also prove to you that the value of the memory is in a memory address that you can locate through the pointer. We went ahead to dereference and print out the value of the variable age using the pointer. So it may look confusing at first, but if you take your time to rewatch these videos and just follow me through and understand the concept, it will become clearer. For me, it was difficult at first until I got to understand it, and I believe you will be able to do that too. Also, we can check out the sizes of the variables. So let's check the size of the variable age first. So printf, the size of variable age is equal to, so we use size of age. So let me duplicate that. Then we want to check that of pointer. So let's say pointer ptr age, ptr age. So new line here to avoid issues, and new line here to avoid issues. So let's clear the output. So as you can see, the size of variable age is 4. An integer uses 4 bytes to store its value. But the size of pointer is 8 because a pointer is an hexadecimal number, as you can see here, hexadecimal. That is why it uses 8 to store its own content or its own variable. I just wanted you to see the sizes, that the sizes are different even though they are using the same data type. Also guys, you can use a pointer in a function as an argument. So let's assume we have a function called printAge. Okay, so printAge takes in if an integer of age. Then let's just do something simple, printf, and let's say you are years old. Okay, age. So let's save that and let's come down here and call this function. So we'll say print age, then let's pass a value to it. Let's say 30. So let's see what the function says here. I'm using a variable first before I use the pointer to get it. Okay, so let me clear the output here. So let's run this. You see, it says at the bottom here, it says you are 30 years old. You are 30 years old. You are 30 years old. Let me comment all these guys out so that it will be very easy for us to see. Okay, so let me rerun this using the function. So it says you are 30 years old. That is, we created the function, this function here, printAge integer age, printf you are 30 years old. Then we called the function here, and that is why we have this result in our code. But we can actually do this also with a pointer. But even before doing it with a pointer, remember we have the age already here, right? So since we've declared the variable here, 25, age is 25, we can use age inside of here to replace this. So we have age. Well, let me move this here upward so that it will be close by. So instead of typing the variable inside, like saying 50, we can just use age, okay? Then we can be changing what we want here. So let's change this to 50. We want 50 here now. So let's clear the output and let's reprint this. As you can see, you are 50 years old. So, like I said, we can also use the pointer instead of age, okay? And for us to use the pointer, all we need to do is just to replace age here with, first of all, we have to go up here and use the pointer. So we say pointer pt arrow age. Then we dereference it here too by calling it pointer pt arrow age. So what we are doing here again is dereferencing. We are dereferencing again. So for us to get it up there, we have to now call the variable ptr age here. And let's change the value in age. Let's confirm that we're actually getting it 76. Let's clear the output and let's run it again. As you can see, you are 76 years old. But we did not even use the integer age anymore. We used the pointer pointing to the address to dereference it indirectly and to get the value. Okay guys, that is it on pointer. I believe you've been able to understand it at least a little. So if it is not very clear, please rewatch the video again and try to follow through with the examples that I've done. Thank you guys. I'll see you in the next one.